So let's observe the definition of a linear differential equation. Definition: a differential equation that could be written in the form a0 of x times y to the nth derivative plus a1 of x y to the n minus 1 derivative plus plus a sub n minus 2 of x y double prime plus a sub n minus 1 of x y prime plus a sub n of x times y is equal to some force function is called a linear differential equation of order n. Otherwise, we say that the dE is non-linear. So let's look at some examples. Let's look at the first one here. It's in y prime plus y squared is equal to e to the x. First, let's figure out the order of the differential equation. And we could easily see that this is going to be first order. Okay, or you could say it has the order of 1. But its order is usually pretty easy to identify. It's the highest derivative in the actual differential equation. Now, is this linear or non-linear? And the answer is, well, let's look at the definition. Does it actually fit the definition? Notice the last term in the definition is actually y. So right here, the last term is y. It can't be y squared, and we actually have a y squared. So in this case, y is not linear here because it has multiplicity of 2. So we're going to say this is non-linear. And the reason is because of the y squared. Okay, so this is a non-linear differential equation. It is of first order. Let's look at the second example. Second example, we could easily see that it is third order. The highest rate of change is 3, so this would be actually be a third order differential equation. And is this linear? And the answer is yes. This actually fits the definition. So this is a third order linear differential equation. How about the next example? The next example, the order is first order. Notice the next example is actually in Leibniz notation, which is a very common form for differential equations. So don't be surprised to use a lot of Leibniz notation. Is it linear? And the answer is yes. And by definition, this is linear. All the rates of change are linear, and y is linear. So this is a first order linear differential equation. The last example there. All right, we can see the order. The order of the differential equation is second order. Highest rate of change is the second derivative. So it's a second order differential equation. Now, is this linear or non-linear? Well, notice that in the definition, we can only have functions of x's and not really functions of y prime. So there's a composition here that kind of sticks out and says it is non-linear. And that composition is actually the cosine of dy dx. That breaks the definition of what it means to be a linear differential equation. Okay, so the last example is second order, but it is a non-linear differential equation.